Hi, good evening, everybody. At least for me, it's good evening. For some of you, it might be good morning or good afternoon. My name is Dieter Riemann from the University of Freiburg and University of Freiburg University Hospital Psychiatry. And it's a real pleasure to be here with you on the occasion of the 17th anniversary of the discovery of REM sleep. And it's my duty today to talk about relationships between insomnia and REM sleep. So this is my agenda for today for the next 15 minutes. I'll talk about basic facts of insomnia, and then I'll switch to the relationships to insomnia and REM sleep. So in 2013, DSM-5 was issued. 2014 saw the publication of the International Classification of Sleep Disorders, third edition, and there was a new typing of the insomnias, now called insomnia disorder. And what is this? It encompasses difficulties initiating sleep, maintaining sleep, early morning awakening. It's coupled with daytime impairments. It has to occur 3 nights per week at least for over 3 months, and that's what we call the insomnia disorder then. Now, how frequent this is? This is quite frequent. This is an analysis of several epidemiological studies from Europe, and what we found is that the prevalence, and sometimes in very big samples, is something between 5 or 6% and 20%, depending on the country where the study was done. And I would suggest that on average probably 10% of the European population suffer from an insomnia disorder with all its consequences. So this is probably, insomnia is probably the most frequent sleep disorder of all sleep disorders. Now, interestingly, if we investigate patients with insomnia in the sleep lab and compare them to a good sleeper, we see different patterns. Here in gray are the wake periods, and this is an insomniac patient who really has very long waking periods, over 3 hours. On the other hand, this is an insomniac patient also complaining of especially sleep maintenance problems, but you see it's more a fragmentation we see here, arousals, short wake periods, and here micro arousals. So insomnia, at least with respect to polysomnography, can take very different forms. And we published a meta-analysis on polysomnographic data in insomnia, and what we found is there are a lot of differences. They are all in red here. Sleep efficiency is decreased, sleep onset latency is prolonged, total sleep time is decreased, more numbers of awakenings, and surprisingly we also found reduced slow wave sleep and reduced REM sleep. And the interesting point here is, and I come to that in detail later on, if we looked at the absolute difference between good sleepers and insomniac patients, it was not like hours, but it was something like 25 minutes. And that is a discrepancy, the discrepancy between objective and subjective findings, which is known now for at least over 50 years, and which has also led to the development of the term sleep misperception, paradoxal insomnia, etc. And we think that as a basic model, the hyperarousal concept is very valuable because it really integrates the different findings. It says we have changes in brain waves, we have more fast frequencies, we have more REM sleep arousals, we have increased heart rate, and we have an increased output of the HPA axis. Okay, so now let's come to the hypothesis. What has this to do with REM sleep? Actually, till 10-15 years ago, nobody thought about REM sleep when we talked about insomnia. Now, we know that REM sleep is the most active brain state during sleep. This is the Pierre Maquet PET study published over 25 years ago, and we see increased brain metabolism from the pons to the amygdala up to the cingulate cortex in REM sleep. And we have very interesting hypotheses about REM sleep. So Matt Walker suggested that REM sleep may be related to emotional brain function. This is a paper from him, I guess published like 2012. And he suggested that during the different REM phases, emotions are somewhat neutralized. And this is due to the fact that during REM sleep, we don't see an activation of the locus ceruleus. There is no noradrenergic nor epinephrine output. And now let's switch back to insomnia. In 2008, we published a study where we looked at differences between subjective and objective findings. And what we saw is that good sleepers tend more to overestimate their sleep duration, whereas people with insomnia more clearly tend to underestimate their sleep. So there clearly is a kind of altered perception. If you suffer from insomnia, you have much more troubles to estimate how long you slept, and you tend to overestimate your waking time. So that was not a new finding at the time, but we had also polysomnography in these people. And what we found there is that if we looked at this discrepancy, subjective minus objective wake time, it did not only correlate with the objective wake time, but it also correlated with the objectively time spent in REM sleep. And the model here was, if we want to explain subjective wake time, in the equation we have to enter wake time, but not stage 2, stage 1 or slow wave sleep, but REM time. So the amount of the time spent in REM sleep would explain some of this discrepancy. And what we also found and published in the same paper was when looking at microarousals in non-REM sleep and in REM sleep, we found a difference already in non-REM sleep, increased frequency, here the red bars of microarousals in non-REM sleep, but much more dramatically enhanced difference in REM sleep. So on the one hand, we found a correlation between REM sleep time and the subjective wake time, and on the other hand, we found increased frequency of arousals. And we thought maybe this explains the altered wake perception. Maybe this is not non-REM sleep where this is happening. Maybe this is REM sleep. And the increased number of arousals may reflect ongoing cognitions, ruminations. These people have the whole night on, and these might not be perceived as dreaming, as you would want to expect, but these might be perceived as being awake. And here's another conceptualization of this. Again, a good sleeper and a patient with insomnia. And what we see here, what is this depicted here, is this altered pattern of especially brief arousals and micro arousals. And what you see here is what also has been shown in several studies, is this altered pattern of the spectral analysis. So what we see in spectral analysis is in insomnia over the whole night, we find an increased frequency of fast frequencies. So these signs of arousal are not measurable on a macro level. Insomniacs do not lie awake for hours, at least not most of them, but it's in the microstructure, and it might happen especially in a REM sleep, which has a unique pattern of underlying neurophysiology and neuroanatomical centers being involved. Though these findings tempted us to go on a series of experiments, we called them the perception of sleep studies, and I'm going to present you these two studies, number 1 and number 2. So both of them are already published. The first study was published in 2018. And what we did here is we investigated 27 good sleepers and 27 patients suffering from insomnia disorder for 4 nights in the sleep lab, and in the third and fourth night they had awakenings from non-REM sleep or REM sleep. This was counterbalanced, and we performed 3 awakenings either out of non-REM stage 2 or out of REM sleep 5 minutes after the onset of REM sleep, and we took REM sleep periods 2, 3, and 4. And we were interested in arousal thresholds. This here is arousal thresholds from the 3 consecutive awakenings. Stage 2, this is stage REM, and you can easily see that there was no difference in the awakening thresholds here. This had been our hypothesis, but this was not confirmed. And what we did next is we awoke people and we asked them for their mental state. Have you been asleep, or have you been awake, or maybe you can't say. And this is the data we have here. I'm sorry it is skipped and I can't go back, but the message is very easy. Judging being awake or asleep was the same in stage 2, but it was different in REM sleep. We had a significantly increased number of subjects stating I was awake out of the insomnia group in REM sleep. Yeah, so that was a significant difference, as we had expected. That REM sleep would tend to be more frequently associated with the statement of I was awake. And here we have the mood ratings for REM sleep. Negative mood is up here, and what we can see is in the insomnia patients that mood was negatively influenced over the course of the night, but not so in the group of patients in the group of good sleepers. So what we found here is, on the one hand, no reduced awakening threshold in neither in non-REM 2 or in REM sleep in insomnia disorder. But what we found is that people with insomnia more often reported having been awake in REM sleep. So they were clearly in REM sleep, and they were probably more dreaming like being awake. And they reported more often negative, not dream contents, but negative mood in general over the course of the awakenings. And we thought, let's have a closer look at this. And with the awakenings, you only have a few measurement points, like you have 3. That's quite a bit to waken up people so much. And then we thought, let's go on let's use another strategy. Let's use event-related potentials. We used 4 nights, an adaptation, a baseline, and we had 2 experimental nights, and we had 50 good sleeper controls and 50 patients with insomnia who underwent this procedure. And we looked at the event-related potentials. We had over 10,000 stimuli per night, so quite a lot of measurement points. And what we found here is the only difference we found in event-related potentials occurred in phasic REM sleep, and we found a reduced P2 amplitude in phasic REM sleep in insomnia compared to the good sleepers. So this is again the summary: reduced P2 amplitude in insomnia disorder, specifically in phasic REM sleep, not in any other sleep state. And you all know that phasic REM sleep means the REM sleep where the eye movements occur, and probably also the part of the REM sleep where more vivid and dreamlike imagery occurs. And this P2 reduction also was statistically significantly related to the misperception if we calculated an index of subjective objective wake time. And we think that this is a mismatch negativity in idea, and this is an orienting response which is not inhibited, which takes place in the insomniacs, which might really contribute or might be an objective correlate of perceiving sleep as awake. And we are first pursuing this strategy on an ongoing study where we try to manipulate when we have pre-sleep manipulations and measure ERPs during sleep as a dependent variable. And the idea would be, is there a way how we can reduce this mismatch negativity? And this is my conclusion here. So what is known and what is not new is that patients with insomnia disorder show a discrepancy between objective and subjective sleep findings, especially in nocturnal wake times. We have increased fast frequencies over the whole night and increased number of microarousals, especially during REM sleep, which stimulated us to postulate that there is something like a REM sleep instability going on in insomnia. Our analysis of event-related potentials revealed reduced P2 amplitudes in phasic REM sleep, which was related to the altered perception of sleep and to an orienting response or an inhibition or a disinhibition of an orienting response. And the speculation we have is that maybe a large part of how insomniacs perceive themselves as awake ruminating happens during EEG states, which are primarily sleep, and actually REM sleep and not non-REM sleep. And what we are thinking about now is, could we manipulate REM sleep to treat the insomnia? So actually, I hope I was able to give you an overview of what we're doing and how and why REM sleep is also important for insomnia. And I thank you very much for your attention.